Another draft physics video production. Feeling like some sort of Lord of the Rings saga. It just goes on and on and on. After a while, you just don't. Yeah, that's it. You just don't care. Uh, Giant elephants, all kinds of stuff. Just nothing surprises you anymore. Ghosts, swords. It doesn't matter. All right, bring it on, assholes. Come on. Yeah. Anyway, comments. Okay. The blackboard is easier to see than the whiteboard. Do I really have to have an argument about that, too? I tend to like blackboards, but, color, obviously, I think is much better on the whiteboard. So if you're trying to do something where color is important, and that's sort of the foundation of the theory, to be able to see it, visualize it, model it, you kind of need color. I could use little dotted lines or something, but that would be very tedious. Anyway, and confusing probably, because then that would imply a frequency, and as soon as you have a frequency, everybody sees waves everywhere. Whoa. Anyway, it is the glare that is the problem. Yes, I've said the word glare in the video. Yes, I gotta lighting is a pain in the ass. So, yeah, I have to work on that. But not today. Anyway. Yeah, so that's it for that comment. Moving on. Alright, opinions are like asshole. Everyone's got one. Gee, that's just so original. I haven't heard it so many times. So you're just the regular soldier doing just the regular thing. I'm just going to throw another stupid looking sword at you. Alright, both of you have invented words. So this is a Theoria commenter. I'm frankly, look, there's no dispute about whose vocabulary has something to do with common language and whose doesn't. Okay? I win by 4 million miles over Ken Wheeler in terms of using regular language. So, fuck you. Just can't you do anything but just talk shit, you people? It's just a shitty, stupid, idiotic thing to say. Oh, invented worlds. Sorry. That only you understand. Again, what, you can't understand 2 plus 2 plus 2? You can't understand, there's 2 kinds of forces and 2 kinds of matter, charge. That's too complicated. Ken Wheeler's invented hyperboloids, instantaneous action at a distance, all kinds of crap. Alright, so there's no comparison. Oh, fuck you. Or you are some kind of genius that we cannot follow. Smiley face. Again, you can't follow 2 plus 2 plus 2. Okay, so you can't be a participant on Earth. You know what? Being a human being, you assholes, requires you to game up. Okay, because your life isn't going to be as simple as eat it, shit it, fuck it, eat it, shit it, fuck it, eat it, shit. No, it's going to be a little more complicated than that if you want to be anything like an asset or productive or useful or an enhancement in any way. It requires a little bit of work. You can't just stink. You can't just go through your life as some fat douche who just does whatever the fuck he wants, whenever the fuck he wants to. It doesn't work that way. So you have all this little jargon down. You can somehow find the cliche to say opinions are like assholes, but you can't find the cliche that says, frankly, do unto others, or pull up your bootstraps, be a man, grow the fuck up. You can't find those cliches. Stupid fuck. I'll remove it just because it's tritely stupid and full of lies again. Okay, just a lie to say my jargon's the same as Ken's jargon, or that my physics is in any way similar to Ken Wheeler's hyperboloid, mystical, magical, fucking sparky bullshit. Alright. There is no proof. I love when people start with that crap. The argument is about evidence. And is there a pile of evidence or not a pile of evidence? Is the evidence for a reasonable person conclusive or inconclusive? Those are the debates, asshole. There's no fucking proof. Yes, there's just argument about the substantialness of the evidence. That something goes in or out of the magnet. So again, this is just retarded. What do you mean there's no proof? That experiment's only been done about 7 million times. you know, but you mean more subtly, like the force. Well, isn't going in and out the same as going in and then coming out? Couldn't you argue that a reflection or a transmission would be impossible to really see, unless there's something else for it to interact with? I mean, if everything's going right straight through it, wouldn't it mean that, oh yeah, stuff is going to come out this end, and stuff's going to come out this end, it's going to come out this side and this side, right? So isn't that just such a bullshit statement? There's certainly something coming out of magnets, all right? The point is, did the magnet make the something, or did the something come from the outside, and is the magnet just saying, hey, I'll reflect it, or I'll transmit it? Isn't that what's really happening, retard? Okay. They need exclamation points in front of the sentence. We don't say the brass gets magnetized because it doesn't. Well, of course it does. It has every attribute of a magnet in the sense that what's happening to the brass is the same thing that's happening to the iron, in the sense that first, well, in the brass it's a little tiny bit more complicated, but first you have to create the little magnetic atom, that is the dipole, and then you have to line the dipoles up. So that's the procedure. Now in iron you already have the atoms are already dipoles, so you don't need to pump them with a current to magnetize them. But for the brass, you have to create a transmission of pressure from atom to atom, so you make the atoms dipoles. But they are dipoles, idiot. I mean, they are temporarily in the state that iron is in that the atoms are polarized. So, I mean, these emphatic little trite statements, you have to be very careful with your language. This is one of the rules of this whole science thing. All right? And yes, frankly, I might say some things that are a little bit wrong. Okay? I'll say words like, and then it pulls it in or something, and I don't mean it pulls it in, but but you're typing and writing, so you got to be a little careful. I mean, the statements there has to be a certain precision to them in a context of language. And so here you're making a joke about language. Well, not really. But there has to be some, there's a point where eddy currents isn't saying anything. Okay, you might think eddy current explains something, but it really doesn't. It's just an assumption that, well, it's got to be electrically caused, and so you use this terminology. But is it really a current? I mean, if the circle is really, really small, is it still a circle? But anyway, eddy currents are induced in it. I know, but that doesn't say anything, right? That doesn't explain how are eddy currents induced in it. Why are eddy currents induced in it? Those kind of questions have to be answered. You just saying it is just saying woo again. And the whole point is what's the byproduct of a current? What's the byproduct of exchanging pressure between atoms? And my simple argument is we can understand that the byproduct of that is you've polarized the atoms. That is, from certain perspectives, they will look more positive or more negative. The electrons and the protons will change their balance between each other. The purple will become bluer or redder. Now, is that complicated? No. Is that a magical world nobody can understand? No. Okay. I would delete your comments just for the fact, too, that type one fucking comment on a video. Unless you're really typing a lot of stuff, then okay, go ahead. If you're doing paragraphs, fine, have more than one comment. But for one sentence, you need Hey, look at me comment? No, you really don't. The magnetic force is very strong in you. I love jokes. Fantastic. Shit. Anyway, perv action who apparently, I don't know, it's kind of a cliche joke, but I mean, he must do drugs. I don't know where he's going lately. But anyway, I don't know. This is supposed to appeal to me. Yes, your convoluted whatever this is gibberish doesn't appeal to me. I'm just making the point. I'm just trying to let you know that your comments are getting strange. Well, I like that whole credit where credit is due jazz. I know, but we're not really at anywhere near any kind of stage to even worry about that, are we? So fuck that. Fuck a conversation about it. But I honestly can't tell if you'd want your relative obscurity to be infringed upon. Well, I have a master plan to take over the world, so I mean, frankly, yes, that is part of my plan. So what do you want me to say? Yes, it's part of what I have to do. That's my whole job. I'm planning on being king. Blah 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 blah. I mean, fuck. There's a lot of baggage that comes with any variation. That's what it says. Of notoriety. Yes, who cares? There's baggage that comes with being obscure peasant also. So fuck you. Despite your wish for recognition, I'll certainly not call your state or set of preferences, you probably need another comma there, a pathology. It's all pathology. We're all pathological. I mean, if you want to take that word apart, I mean, we've all been put on paths, okay, by circumstances, and they're all psychotic, frankly. They're all not conducive to the mission, which none of us are informed we're here to be, which is somehow useful. I mean, it just doesn't occur to anybody to let you know that's your obligation. Anyway, if you'd feel better about people disturbing your findings, distributing, okay, if you'd feel better about people distributing your findings, I just don't understand what's complicated here. All right, I've made it clear. I mean, I want to have the argument. You see, I want to prove the case. I'm a lawyer. I want to prove the case. That's all I want. It's not any more complicated than that. I want my opportunity to fight and win. That's it. Nothing else. I want a fair fight. Period. I don't want somebody to steal everything I'm saying. I don't want somebody else to say they thought of it first. I don't want somebody else to... Yeah, it's fine. Somebody else can explain the theory, but I mean, obviously they ought to go back to the source so it doesn't get corrupted. It's like Einstein's little theory got totally corrupted by all the other jerky nerds, and he was left with nothing. It's just like they took it from him and turned it into a horrible, disgusting thing. Anyway, not telling what brought them to the conclusions. Why would I feel better about that? I can see why. I don't know what you're talking about. See, I don't know what you're talking about. How is this relevant? I thought you got the mission here, which is to antagonize me with, redundant and stupid. What about this? Well, what about, that kind of thing. Isn't that what you're supposed to be doing? Anyway, sorry about the multiple comments. So if these were in multiple comments, yeah, you should be sorry. Would you rather I add them via comment edit? I don't know. I don't know what that can mean either. This comment didn't appeal to me either. Sorry, can't find the relevance in this. Sorry, just can't find it. So I'm going to delete it. This is just irrelevant, whatever it is. Whatever your purpose was in this recent exchange, I don't get it. All right, live free or die, which is more just absolute nonsense, right? Live rational or die. Live in a reasonable world or die. Uh, live with the reasonable or die. Do the right thing or die. I mean, there's lots of things you could say, but this live free. Free to be what? An asshole? I mean, isn't that all? The people looking for freedom don't want freedom to do anything but be an asshole, right? They want to be free to be an asshole. They don't want to be free to do anything useful. So, fuck it. Fuck your live free crap. Live right or die. Yeah. Yeah, that's it. I like that one. Live right or die. Put that on a cap somewhere. Hey, DraftScience, you probably have the free time. Yeah, fuck you. I mean, like, this just happens, right? Yeah. You just sit here and, oh, yeah, it just all falls into place and you don't have to do any work at all. No, it's arduously tedious to have to think through all this crap and combine all these things the right way and this puzzle doing. This isn't like some kid's puzzle where there's 4 pieces and you just go, oh, okay, this is the A piece and the B piece. It's not exactly that easy, shithead. All right, check out the book Principles of Quantum Mechanics by Paul Dirac. So I've already pointed out how I think Dirac is like Bohr. He's a huge giant piece of the corrupt foundation of physics. He has exactly the wrong attitude. It's all about some mathematical, statistical bullshit rather than anything called reality, right? So in Dirac's universe, we're not people, okay? We're just statistical data. And there's a certain number of us, right? So there's a certain number of bald people, a certain number of almost bald people, blah, 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 blah. And so you're just a statistic. And so if I know you're, like if I show up and I go, see, I still have some hair, then I'm not bald yet. And so I now, statistically, we know that my doppelganger opposite must be somewhere else, right? So it's that kind of nonsense, right? Just because, oh, yes, and it's perfectly rational in a conservative universe. This is how it's going to work. If there's arrows, and I pull one out and he's right, well, I know lefty is still in there, right? It's that simple. So it's just statistics, and they've turned this into some sort of physics. And it's not physics; it's just statistical analysis. So yes, when you're going to analyze statistics, that's fine. But it's this idea that they're saying somehow the statistical analysis is better than me showing up on the shore of America and shaking your hand and saying, hello, American. Oh, I see you're an American who's this tall and this fat and blah, 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 blah. And I can, and if I meet 10 of you in a row who are that, then I know, well, the rest of the real assholes must be in some other room somewhere because I've got the statistics. I mean, how else can I say it? But Dirac was just obnoxious to acknowledging, okay, that anything is real. And so it was just this way of saying that I just turn everything into what I know it to be statistically. And it's just stupid because it, like I said, it then gets you into this silly nonsense where you pretend because I haven't been identified yet, I don't have an identity. So that's what he does to everything but through statistics. It's just say, because he hasn't met me yet, and he hasn't met you, that we're some sort of generic unformed thing that is in a superposition of me and you. Because statistically we're different, so statistically we're both. Until somebody shows up to say hi. And he takes that seriously. Like somehow that's seriously how the little universe works. Like, we know if he tried to sell that crap to, like, say, England before they went to America, or Europe, before they came to America, and if whatever, Christopher Columbus had this dopey theory that, yes, we're going to meet people who are in a superposition, and they don't know who they are until we go over there and show up and shake their hand and find out who they are. Then all of a sudden they poof, they transform from you to me, or from me, you, into you, and then a me has got to be over there somewhere. I mean, it's that silly. So they're just basically saying that, oh, somehow on the little universe, all these rules change. So the big universe, we know none of that shit's happening. All right, people aren't driving down the street in a superposition of 7 billion other human beings. No, they're one individual statistical human. All right, they're not everybody. They're not fat and thin and tall and short and have cancer and don't have cancer and all this kind of crap. No, they're not. It'd just be silly if somebody suggested that was how the world worked. But in physics, it's okay because it's run by a bunch of mathematical, geeky, asshole fucking cunts. Yes, yeah, I really am getting sick of it now. You see just how they've perverted reality, merely to do statistics, and they'll admit, like Dirac admitted, oh, you can do it all the classical way. The only time you need his math is when you can't see anything at all. So his way only really works when you're in complete darkness. Gremlin theory works then. It's that stupid. Fuck. You're obviously living free to be an idiot. Free to be an idiot. The first 20 pages or so have no maths and don't require much background. Yeah, it's just a fairy story. It's just a fairy story. Look, we have these tiny indications, right? He brings up the two-slit experiment in a vague way. He brings up experiments in these vague way. He doesn't go into any of the details of the experiment. Doesn't explain how, he says interferometer. He doesn't explain how the damn thing works. And just says that, oh, it's all superposition. That's why, these weird things happen, is because things are in dual states, because we know that they've been broken into these waveforms. We don't know any of that. He doesn't challenge a classical explanation. He just claims it doesn't exist. All right. The first 20 math, much background. It's all about experiments and how quantum theory came to be. Yes, it obviously came to be because people decided that it's easier to just deal with these variables than attempt to model something in a real way. Draw it. They're lazy, frankly. What else can you say? They didn't understand how it worked. All they knew is that there was a connection between variables and outcomes. And so, yeah, if that's all you got, that's all you have. But the whole point of like a Faraday or somebody is they were seeking a better model than that. They were seeking the faculty to be able to draw it. And these assholes gave up on that. Dirac was the most important scientist in quantum theory. Well, at least you're qualified by that, saying quantum theory. So insanity, physics that isn't physics, delusional fantasy theory. So you could just say that, delusional fantasy theory. Dirac was the most important scientist in delusional fantasy physics. And one of the greatest physicists, the greatest storytellers, the greatest, let's all believe in fairy godmothers and forget about this idea that you actually have to earn it, just wish for it, of all time. I mean, that's just such crap anyway. Really, crap. I don't know how you even say something like that. I mean, obviously Dirac was building much of what he was saying on what other people have already said. So, I mean, it's not like he invented it. Give your thoughts on it if you can. Yeah, well, my thoughts are you're clearly way up his ass for what I can't see as any good reason. So anyway, this is just even the beginning of Dirac. Dirac is the whole cause for why we have these idiotic notions of antiparticles and annihilations and all of this other nonsense. It really just has to do with the statistical facts. Yes, of course. If I go to America and I know the statistics are 50-50 for something, like half of them are men and half of them are women or something, it's 52-48 or whatever the real numbers are. And then I know that if I meet the first person I meet is a male, then I know there's a statistical likelihood, okay, a small one, but a statistical likelihood that the next one I'm going to meet might be female, because now I've changed the balance by meeting one of them. Yeah, that's true. But does it mean anything? I mean, realistically, can't you know that in a classical way? You don't need to superimpose everybody into nothing to realize that, do you? You don't need to be turn everybody into statistics to understand that. I mean, a better analysis might be like flipping a coin or doing something that seems random, because those facts aren't built into the physical structure. See, I mean, a classical model says, okay, you're doing the jelly bean thing, and there is actually only 10, green jelly beans and blue jelly beans. And so when you start doing this thing, it's an actual fact, okay, that if you get all 10 blue ones, like cards, at the casino, they counted cards, they could game the system, because the statistical analysis doesn't mean anything. Probability doesn't mean anything anymore when you've seen all the kings, right? When you've seen all the kings out of the deck, you know there's no more left. So it's not a statistic. Statistics will get you in big trouble. You don't want to go by statistics because there's an absolute number of them. But in other kinds of probability, like flipping coins, well, it's not like the coin only has a certain number of heads in it. It only has a certain number of tails. So there's no physical boundary that obligates the other 10 tails to show up somewhere. They don't really exist because you're using something metaphorical to physical reality, not something that's really bound by any rules of conservation. There's no rules of conservation of tail flipping or head flipping. There just aren't any. Okay? Now, probabilistically and statistically, it will turn out that way, but it's not for the same reason. It's not because there was a physical boundary that obligated it to happen. There's just a practical boundary. So I don't know. I don't know what to say to you. Okay. Give your thoughts on it if you can. Okay. Those are my thoughts. Is Dirac is a really bad example of science. It's a bad example of doing physics. He had completely the wrong attitude. He was like a Feynman. He was just saying, "Don't think about it. I'm smart. I thought about it. There's no way to figure it out. So let's just do math. Let's just do statistical analysis and say that's physics." And to me, it doesn't even come close. Physics is understanding the difference between flipping coins and pulling cards from a deck. Physics is understanding that one is bound by real physics and one isn't bound by any real physics, because it's an abstraction. It's one step removed from equilibrium equations. It's one step removed from the idea that there's energy going this way and energy going that way, and if I capture the energy going that way, I've created an imbalance in the universe where there has to be a bit of energy somewhere else going this way still. Those rules are physical. The rules governing flipping coins are removed from the physics. The physics is in the flipping, okay, but that physics is not randomized, it's not pure, so that physics can violate conservation. You can flip way too many heads, but only if you're flipping badly, non-randomly, which is always the case, frankly. All right, let's see what he's... Okay, since you really seem to oppose wave-particle duality idea, yeah, and I don't know where you think Dirac demonstrates any proof of it, that the whole thing just sounds like such horseshit. I'm going to assume that the single thing goes into this thing and somehow gets split into two things, and that the two things are superpositions of what the original thing was. That means it's somehow the yin and the yang, and somehow all the left components are in the left rail and all the right components are in the right rail, or something like that. Or no, it's even more superpositioned than that. They're just a mixture of the two things somehow. And it's stupid. It's made up. It's nonsense. There's no reason to believe any of it. It's just an invisible man. It's a fantasy gremlin excuse. It's like just inventing little magical creatures that steal all your stuff. I mean, it's a silly explanation for why you lost something. Shit. No. Frankly, I don't know what to do with it. I'll leave it there, but it's just crap. No, I won't leave it there. Yeah, I will. No, I won't. Yeah, I will. Yeah, I read it. It's enough. Fuck it. It's a horrible distraction, and it implies something. It implies there's some argument Dirac made. So if you can find the argument, post it. But there's no argument. I've read it. There's no argument. There's no decisive proof that somehow quantum mechanics is right and classical physics is wrong. There just isn't there. He's just saying this is easier. So, and can't we all say that profiling is a lot easier, okay, than actually going out there and giving people what they deserve. All right. What you need is evidence. Another fucking cunt of a name. The arrow of magnetic force line is just a representation of the direction the line has. So, no, it isn't. I wish they understood that, but that's not how Faraday understood it. It's not really how Maxwell understood it. Okay, they broke the concept. They used it right in one sense, and then they broke it, okay, by not realizing what they were doing. So I could analogize it to gravity, right? And I could say the Earth orbiting the sun makes a line, right? Now, you can know, and I can know, that the line the Earth travels on, the path it travels, is arbitrary. I speed up the Earth, it's a different line. I change the ellipse, it's a different line. I can do lots of things to change that line, and it'll still orbit, but the line will be a different line. And that there is nothing, there's no single force, or there's no, the end force is not traveling in the direction the Earth travels. All right, so we know that that's made out of the Earth's velocity, and that has a vector, and that vector is constantly changed because it's constantly mixing with another force. And it's the mixtures of the two forces, the velocity of the Earth in one vector, and the acceleration of gravity in another vector, and that's deciding the line. But if you were to say which way are the forces going, you would understand that yes, the Earth has a force going this way, and gravity has a force going this way. Those are the real arrows. Those are the real forces. So that's what I've been talking about, is this distinction between understanding what a field line is and what a line of force is. And I would argue to you that they got it broken right from the beginning. Okay, they invented the concept and they immediately broke it by interchanging the two concepts. Thinking a field line, the line created by the pressure a field creates, is the same as the lines of force. So let's play with that. I believe we have a place here to play with it, so we'll play with it. Okay, so here's a basic page going through some of electrodynamics, and it's the same difference really. And I don't know how well these illustrations will show up, and so I might draw it, but whatever. So here you have the basic idea of what a charge is doing, right? In this idea that if I put a positive test charge in, the arrows are pointing out. If I put a negative test charge in, the little red dot, okay, right here, all right, then the lines will be moving in. Okay, so we have this idea that somehow the pressure changes inversely, okay, depending on the charge. And that's the interesting feature, okay, that 1 minute it's repelling, the next minute it's consuming, it's absorbing, it's attracting. And it all depends on the quality of the thing I put in the field. So these arrows are representing what the field looks like, okay, to something that sees, let's say, red light. But to something that sees blue light, it's exactly the opposite. Nothing's getting radiated. It's dark. Okay. And so those you would call the lines of force. And the idea is, so here they just do the inverse of it. Okay, so here they have a positive charge and a positive charge, which means the positive charge will be expelled by the force. Here they have a negative charge and a positive charge, so now the lines are going in. Alright. So for the sake of mathematics, they basically established a preference, you could argue. A statement that we're going to draw the positive one with the arrows going out, and we're going to draw the negative one with the arrows going in, and in a sense we're always going to assume a positive chest charge, essentially. We're going to give the default state. So they create a default state that allows the mathematics now to know the difference between. To create the right hand rule, you sort of have to establish what's left and right. So you have to sort of establish a board to draw it on. And so this is just a default premise. It has nothing to do with the truth, in the sense that it's arbitrary which one you assign these values to, as Benjamin Franklin got it backwards. So this is even wrong in the sense that we do know that the positive end isn't the one producing. Okay, it's the negative end. But whatever, the excess of electron pressure. So they have the numbers backwards. The Q is the low pressure. The negative is the high pressure. But this is the established track. But still, the field lines are going in the right direction, as you can see. All right, and then they figure out through Coulomb and whatever the other guy was, and Gauss, that these lines are essentially a mathematical tool. So if the charge increases, you just make more lines, and then when you put something in that field, you just count how many lines it intersects. The more lines it intersects, the more force that will be applied to it, the more pressure out or the more pressure in. And it's that simple. So the lines they're just representing what could be an infinite number of rays. So it's like drawing the sun and recognizing that if I drew the sun and I could draw 100 lines coming off of it, and I could statistically know that each one of those lines, the separation between them, each pie slice represents 1 million watts. Okay, so I could establish a 1 million watt line depth, and then I can figure out at a distance how many watts are hitting something by just counting how much of the pie hits the surface, and it'll tell me exactly how much there is by the inverse square law. Alright. And so they haven't still broken it yet. Okay, but they're going to try to break it soon enough. So this is just pretty much a copy of the other one. I don't know exactly why they wasted time throwing that in there. So now they're saying what's happening with an unlike test charge between two opposite charges, and that all the force lines would be in the same direction. It's getting pushed by one thing and it's getting attracted by the other thing. So the two add up in kind of an obvious way. And so here's where the lines break. So this is very good, actually. It's showing exactly how they broke the lines, right? Because they're showing the path of a test charge. Now, technically, the lines are still in the right way, right? I mean, the force is coming perpendicular off the surface of the little plus charge and is going in perpendicular to the negative charge. And that's exactly how the force is acting, right? The negative charge is saying, come to me. The positive charge is saying, get the fuck away from me, pushing it away, pushing. The other one's pulling. And the boat's going to go straight through and straight across. But that representation only works for the one case. Only the one case are the two lines the same. That is, the line showing how the boat will move, right? The boat that's getting pushed by the current. So there's a current being created by the plus charge. It's a current going out, perpendicular. The current by the negative charge is a current going in, a drain. Okay, so you have the two opposite things, and yes, right in between them it'll be a nice straight line. But the way the boat moves, okay, when they're further apart, is going to have nothing to do with the fact that they're still just drains. One's pushing lines straight out. One's radiating straight line force out. The other one's pulling straight line force in. And all of that's going to break as soon as they decide to put that charge, that little boat, off that straight line between the two. and this is where they broke. That's where they turn a line of force into a field line, into what will a boat do. So just like looking at iron filings, you're looking at what iron filings do. You're not looking at what the force is doing. You're looking at what the force does to boats. And the two will be a different drawing, you know. So here they bend it. Here's where they ruin it. Because now they say, what does the boat do when it leaves the plus charge at one of these other angles? Well, it's not going to go a straight line. Okay, the boat won't travel a straight line. But the fact is the force is still pushing with straight rays. It's still pushing with things moving in a straight line off its surface. That's what's hitting the boats. And so yes, the path will curve because the two different forces are going to be added up. So this gets back to superposition, which is now this word they've ruined, right? Superposition used to mean that when you have these two forces, the forces don't add up. The forces don't interact with each other. They add up when you put something in there. Then once I put a boat in there, then if I'm shooting torpedoes, you know, don't explode but just push. If I'm shooting torpedoes from different locations at different frequencies or rates, they're going to have the influence of them will be decided by the boat. The boat will do the math. The boat will say how many hit me this way and how many hit me this way, and it will move appropriate to that amount of energy that hit it. Okay? But there's no math done by the torpedoes. The torpedoes don't bounce safe of each other. They don't do the math ahead of time. But this is where the lines got bent. So the lines of force now look like they curve, and they don't. And this is what Faraday was kind of arguing. So he was arguing against an ether because he saw these lines of force and was basically saying these are tubes, you know, of force. And that's the wrong way to think about them, obviously. They're not carrying, they're not conductors. So in a way he was thinking of them as conducting pressure along these paths. And they're not conducting anything. They're arbitrarily drawn to explain if you add up the two forces, the two rays, what are you going to get hit by? How many torpedoes hit you from this direction? How many hit you from this direction? That's the way it has to be appropriately visualized. So, like I said, this is just a great example showing you how lines of force, right? They showed you the lines of force, and then they showed you the lines of force, sort of, and then they turned them into field lines. Lines where which way will a boat go? Okay? Which is different than which way are the torpedoes going. And then you can create this whole pattern and put these little arrows on it, and clearly this is the way the boat will move. It will move on these paths. There's no doubt about that. But that's not why it's moving on those paths. It's moving on those paths because these lines are dead straight. All of these lines are dead straight radiation. And you're just saying how many torpedoes from this guy are mixing with torpedoes from this guy. And what's the mixture? They have sort of an opposite effect on each other. You know, one pulls and one pushes. And so you're just saying what's the effect of being pulled and pushed. And that's how these lines get bent. But there's no force traveling these lines. No torpedo travels these lines. The torpedoes move dead straight. The boats travel curved paths. And this is the fundamental error of physics right here. It's a huge, monstrous error they made, was to be fooled by these boat paths and not realize, no, the force is still just torpedoes traveling straight line paths. Alright, so I don't think we're going to get... See, they're just showing you now the different arrangements. Plus, plus, minus, 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 plus. So they've given you the same... But again, they do it exactly the same way again. They show you on the dead straight path. So where the field... Well, the torpedoes are going to look just like the boats because they're all on one plane and they're all in one line. So obviously the torpedoes will look just like the boat. And then they just go from force lines to field lines and just break the whole thing again. And break it and break it and break it. So this is just saying to you, if you're getting hit by torpedoes from this direction, you're getting hit by torpedoes from this one. If this one's radiating a force and this one's radiating a force, what are you going to do when you're sitting there? Well, of course you're going to move this way. If torpedoes are hitting you from this side and this side, yes, you're going to move that way. You're not going to move this way, or you're not going to move this way. You're going to move a mixture of the two, because the boat does the math. The boat figures out what waves are hitting it, and it moves the direction the waves are hitting it. And of course the boat can have a motor and just complicate the thing even more and draw even another more ridiculous line. But that's what I've been trying to explain, is that the lines of force, as they should be called, are the radial straight lines. None of them ever curve. They never curve like a light bulb. It's creating straight, dead straight rays. They go billions of light years through space in a straight frickin' line. The lines of force are always straight, and it's only when you put something in it that can be affected by the force does the math take place. Does the boat decide which way the water's moving, and adds it up. Yeah, really. I mean, I shouldn't even have to say any more, right? I mean, so this is just this. See, it all depends on how familiar any of this stuff is to you. So if this is the first time you're seeing any of these lines, maybe you're confused. But I just mean, this is the foundation of understanding gravity and charge and any of this stuff, because this is the stuff that Newton and these other people were always, Faraday and Maxwell and all of them, all talked about, was the fact that it appeared as if gravity was being governed by a straight line force. So, you know, they understood, okay, that the mechanism that was doing this thing, no matter what you made, whatever you said it was being created by, could be, all right, really easily understood as a straight line force, and that there were anything that would come into a gravitational body would be affected by hitting those lines of force, and that they, okay, would change its direction. And so they understood that this thing could have velocity and a direction, and its velocity, if there was no gravity, it would be going this way in a straight line. It was a straight line it was traveling. Okay, it's even like Einstein stuff, you know, the straight lines all get bent. Well, they really don't. So there is no bent geodesic. Okay, it's really just dead straight lines, and the bendedness happens when you put something in there. Then the line gets bent, because now you're adding two forces. You're adding the force going this way in a straight line, and you're adding the force going this way in a straight line. And you're going to say, where's that boat going to go when you add those two things up? Well, the simple truth is it's going to go this way. And then the next moment it's going to go this way. And the next moment it's going to go this way. And the next moment it's going to go this way. Now these are classical drawings of angles, and the whole math is based on understanding this is how they really draw the physics. So they know it happens this way. They know this matches exactly why they get the outcomes that exist, why things move the way they move. And this is how they'll take that movement apart and understand it. And they'll understand this whole frickin' thing, that these are right triangles, and these are the angles equal each other, and all, you know, all of the Pythagorean crap, and the whole pi crap with the circumference, and, you know, the relationships of how this radial force is going to affect something. But there's a huge distinction between this line that the Earth travels with an arrow on it, okay, it has an arrow, and understanding what causes that line. This isn't the line of force that the Earth is traveling. It's not traveling some track where it's being pushed in a round circle. No, it's being pushed this way by its own momentum, and it's being pushed this way by gravity. And that addition happens when you put something here. Yeah, I really shouldn't even have to go any further than this. And so what I've contributed to this physics is just the idea that the forces are come in these two types, okay? And the matter comes in two types, all right? And that they inversely react to the two types. So what's attractive to this object is this force, what's attractive to this object is this force, and vice versa for the repulsion. So they're mirrors, they're opposite mirrors to each other. If you were to make this red and this blue, you could just understand that this is a blue mirror and this is a red mirror. They have an inverse function. And it gets a little more complicated in the sense that they also inverse function in the sense that the way they react to, say, a head-on collision is in one case they reflect, and in the other case they bisect the interaction. They mathematically, well, I didn't draw that arrow straight. They just they just changed the dimension in which the interaction took place, in a sense, and just moved the opposites into the other dimension. Well, anyway, I don't want to make it more complicated than it has to be. But once you have this differences, these tiny little differences, that's all you need to have a universe that gets quite complicated. Right. So do I need to say any more on this particular subject at this particular time? No, it's just like I would just say it's the critical error in Faraday would have been twice as great a scientist if he would have got that right instead of wrong. That was just a huge error for him to convert force into field lines, to be fooled by the path of the Earth and lose sight of the fact that the thing that's really creating the path of the Earth is energy going in these straight lines, and that the path is just a manifestation of those straight lines. Alright, it's probably enough. Alright, maybe later on, I don't know. Probably need to do a new overview video just because there has been a lot of refinements. Yeah, still waiting on the animation guy. Kind of, he's going to make it bigger and better, and it didn't happen. So I don't know exactly what's going on, but maybe I'll play with the old code and see if I can get it to do what I need it to do. But anyway, working on it. And so till the next time, in process. Blah blah blah. Blah blah.